Hi guys, Dr. Justin Souther here, going through semester test 1, and I'm looking now at question 12, which was again a nice little easy 2 marks, provided you have swatted up on predicate first order language. Okay, so we were asked to negate the statement given below. It's a statement given in mathematical predicate first order language, and we're asked to find the negation of this sentence. So we want the negation of there exists x is an element of R such that x is greater than 0 and x squared is less than 1. Okay, so the negation of, that's logical equivalent to the negation of a there exists is going to be a for all x is an element of R. We have the negation of this sentence here. And now we need to use De Morgan's laws, at least one of De Morgan's laws. We've got not this and this, so that's the equivalent of not x is less greater than 0. The and becomes an or, not x squared is less than 1. You could have done this in one step, actually. It might have been a little bit simpler. Okay, so we've got for all x is a real number, not x is greater than 0. Well, that's the same as x is less than or equal to 0, or not x squared is less than 1. Well, that's the same as x squared is greater than or equal to 1. And that is the negation of this sentence over here. So you've got a sort of a half a mark there and a half a mark there. Of course, you could have done this step, definitely done this step in 1. You know that the negation of that is that, and the negation of that is that. Less chance to make careless errors also if you don't write out that third line over there. Okay, question 12 part B, you were asked to determine the truth value of the statement. There exists an x in the set of real numbers, so we're looking for a real number such that x is greater than 0 and x squared is less than 1, and you were asked to motivate your answer. Now, the vast majority of you said that this was false, and said that no positive number has a square less than 1 because squares are all positive. Yes, well now of course squares are positive, and squares of integers are all positive and bigger than 1, but what most of you have left out are all the fractions between 0 and 1. And in fact, this statement is true. Why? Because you can let x be any fraction that is between 0 and 1. I'm going to take a nice easy one. Let's just take x is equal to half, and then we've got that x is certainly greater than 0, which is what we want over here, and x squared is equal to a half squared, and a half squared is a quarter, and a quarter is less than 1. So any fraction that is greater than 0 and less than 1 is certainly greater than 0, and its square is going to be less than 1. So just be very, very, very careful when you see something like that, the real numbers, that you don't forget about the fractions. Certainly, this would be false if this said there exists x, an element of the integers, such that this is true. But because we're allowing fractions, and in fact irrational numbers, this statement is in fact true. So that was a mark that a lot of you lost unnecessarily.